You're listening to Peerless Industry Radio, your source for educational content on the cutting edge of industrial process solutions. In today's episode, we will be developing an understanding about considerations to keep in mind when navigating the world of specifications as they relate to valves. Before we get into the episode, this podcast is produced by Peerless Inc., a company defined by more than the products we supply. Based in Western New York and serving customers around the country, we are an ISO 9001 certified organization in our quality management system, providing reliable on-time quotes and deliveries that supply our customers with the quick turnaround times they need. Expect our efficient service process to provide quality kits shipped directly to your facility with all the proper documentation for any compliance standard. Peerless also brings to the table 3D CAD and CAM services from our expert application engineering support team. We utilize advanced ERP and MRP systems for a streamlined and AML-friendly experience to every one of our clients. We are Peerless, where ideas meet solutions. I'm James Lamb, your host for today, and joining us will be Kevin Renaud, Vice President of Business Development here at Peerless, and a 15-year veteran of the company, with a diverse professional background spanning from management and sales to collegiate instruction. He's a core member of our team, knowledgeable on all things process components and the services they require. Also joining us this episode will be Dan Morgan, a Clarkson University mechanical engineering graduate who leads our engineering and quality management teams and has 11 years of experience upholding our services and products to the highest standard. In today's episode, we will be welcoming back Kevin and Dan to discuss with us what thoughts and considerations there are when selecting the right valve for the right application.
Hey, James.
Hey guys.
Hey, Dan.
We're back.
Hey, Dan, I see you finally got a haircut-ish.
There was some feedback from the last one that made it pretty apparent that it was necessary.
Well, my barber hasn't closed in a year, so. Anyways.
Nice.
So starting off the episode today, what are some baseline areas of specifications to think about when picking out the correct valve for your needs?
That's a good question, James. First, it's important to state what a basic valve is. There's so many great valve manufacturers globally that manufacture valves that do one of three things: either stop flow, open flow, or control flow. And valves work. I mean, they just do. And they're all made, again, to certain standards. Here in the US, we use API, which is American Petroleum Institute. They govern different aspects of the design of valves, whether it's the wall thickness, the pressure class, material designation, the trim materials, different things about fugitive emissions and materials. And I mean, it's all built to make sure that every manufacturer, when they build a Class 800 valve, it's every bit is a plug and play is every other manufacturer that builds a valve to that standard. So really, that's the base level of really manufacturing a valve.
So with those things in mind, what are some of the circumstances that would require you just to meet a standard, or in other situations to go beyond that standard with what you have in the valve?
Right. This is where different levels of risk come into play. So if we're talking about a very low level of risk, I mean, naturally, wherever there's a valve in place, there's some pressure, maybe some temperatures in there. So it's always risky, but there's certainly areas in systems where the risk goes up exponentially. And that would really lie in areas like a chemical plant, power plant, oil and gas, something where if something leaks or if something explodes, it's detrimental, not just a problem. So specifying engineers go to great lengths to realize that the minimum accepted standards just aren't good enough. And what oftentimes it does is take a standard $40 or $100 valve and turns it into a $1,000 or a $1,500 valve because of the pedigree that's required. But again, it's important to remember that these valves live in areas that we like to call where people meet pipe, and it's a dangerous place to be. There's temperatures, again, pressures, and if anything should go wrong, again, catastrophic. So no amount overpaid for a valve that helped prevent an accident, an injury, or worse is too much. So that really is why they go to great lengths to make sure that they really have a valve that's quite oftentimes overspecified. And these specs can sometimes be literally hundreds and hundreds of pages.
When you receive a document of that length about a valve, what does it look like, and sort of how do you go about approaching and understanding it?
Yeah, so hundreds of pages is not an exaggeration. They're not all that long, but some of them are. So yeah, depending on the size, the location, severity of the service, like Kevin mentioned, there's potential variety of different valves that a spec may apply to. There's easily enough text and charts and references to span that much length and possibly even more. So like Kevin was saying, though, it's all in good faith. Sometimes it feels like the intent of the spec is to make your life miserable, to frustrate you. It's really not. It's there's a process engineer, a safety engineer, reliability engineer on the other end of it, who really their job is to mitigate the risk of any potential hazards of where those valves are installed. So yeah, they're no two specs are the same, but they definitely follow a similar general flow. There's generally begin with some sort of scope, outlining the details of the project, or what the spec applies to. Usually a section about additional references, and those are those industry standards that Kevin mentioned, like API and ASME. Anything additional to the spec itself that might be referenced somewhere within it. Then there's usually a section with definitions that kind of describe the specific terms and what things mean to the specific end user. So there's no interpretation that might be needed. Then it really starts to get into the meat of the situation, where it starts to cover things like what types of valves can be used in what services. What are the material selections that the different types of valves require, based on where they're being installed and what services they're being installed into. Valve design itself. So in addition to like some of those standards, ANSI B16.34, there's other standards that need to be applied. Another common one is distinguishing between a forged or a cast valve. NDE, and any kind of additional testing. That's a huge part of it. Very important. That's where that extra $1,000, $1,500 worth of testing or worth of cost really comes into play. AMLs, so like approved manufacturers lists, tagging requirements, supporting docs. It's a lot, but yeah, those are all the things that go into really defining how a valve needs to look and act, and what it needs to come with when it shows up at a project site.
It does sound like a lot of information and a lot to kind of process and be responsible for. With there being so much of that information around the details of a valve, who is responsible for being sure that what is described in that documentation lines up with the spec that you're requesting?
There's a lot of people in the line of custody, starting with the designer of the spec, the end user, engineering firms, equipment builders, packagers, contractors, distributors, the valve manufacturers themselves. Anywhere the spec flows down to, all parties involved essentially share in the responsibility of ensuring that compliance. So yeah, it's a lot, but if a valve spec does come across your desk and you're being asked to ensure compliance, you gotta read it. And I don't know if that's like an obvious thing to say, but I think it's important to advise that if a spec falls into your domain at any point in time, it's going to end up on a PO, it's going to end up on a contract. You really got to get an understanding, of the spec and really some of the subtleties that might make a difference with, what portions of the spec are applicable to different portions of the project. A lot of times, the further away you get from the source, the less and less information about how a particular valve is used becomes available or becomes known or becomes shared. So as a valve spec gets passed down, it's really important to kind of maintain that lineage and really express as much information, as much detail as you know about the valve, where it's going to be installed, what the service is like, what are the operating conditions, to that next entity in the chain of custody, to make sure that they're, reviewing the appropriate part of the spec. So I think the instinct sometimes is to skim, to try to just, breeze through the document, to only find the portions that, you think are going to apply to you, or the portion of valves that you're supplying. But, realistically, it's not written with your schedule in mind. So there could be a clause that's buried somewhere in a paragraph in a section that you're not paying attention to, that identifies a specific process condition of one specific valve that all of a sudden changes that commodity on the shelf $150 valve to that $1,500 valve that Kevin talked about.
Well, it sounds like there's a lot of due diligence that can be gathered to make sure that you're complying to what you've actually requested. And after seeing what requirements you have for a valve in your own use, and while going through some of that documentation that we talked about that was provided, what are some types of tests that you can look for that will ensure that you're getting the quality of valve that you require?
Yeah, Dan earlier mentioned NDE, and what that is non-destructive examination. So although these valves are all built to certain standards, where the risk is incredibly high, they want to go above and beyond. And that's where this concern of NDE comes into play. So, for example, CMTRs, or Certified Material Test Report, typically shows the chemical makeup of any material, and it's lot traced by heat number. But oftentimes that's not good enough. They want what we call PMI, or positive material identification. So they literally want you take an analyzer, a handheld analyzer, you hold it up against a component, and it spits out the chemical makeup or the recipe of that particular material. And you compare those readouts against known, again, ASTM standards for what material makes up stainless steel, or what material, you combine to make carbon steel. So they want that extra level of security as well. So that's one thing that's requested. And again, failures cannot be tolerated. So they go to great lengths to make sure that the integrity of the actual body and bonnet of the valve is good. So there's more additional tests, liquid dye penetrant and mag particle inspection. Those are both to identify surface layer or very, very subsurface layer cracks or fissures in a material. Really cool stuff to see too. If you ever want to YouTube about mag particle or liquid dye penetrant, it's really cool how they do this. But there's also the extra level of ultrasonic and radiography, where they actually look at the internal, not just the surface layer, but they can actually look at the valve itself. So that can really add some serious money. And this is really where most of the additional costs for these highly specified valves come into play. It's additional hydro testing, additional, this and this, and it just starts to add up because no one normally makes a valve that has all of these properties to them. So I guess one thing that comes into mind is we had a spec Dan and I worked on together not long ago, and there was a call out for no welded on flanges. The manufacturer was not allowed to weld flanges on. So we went out for quote. We got a quote, a long-term factory lead time. We had no idea. We had never seen this before, where a manufacturer would factory order valves or build them to factory order and actually weld flanges on. So what happened is, because they welded flanges on, it kicked off a whole new round of RT or X-ray. So every single valve now, because of the weld, had to be X-rayed to make sure that weld it had great integrity and no stress, and that would be okay. So that slowed the project down. We got through it. It slowed the project down. There was additional expense, but that was just one of those pitfalls. And again, it's all about the NDE. These are the things hiding in the shadows that can really, really get you if you're not aware of what you're looking for.
Yeah, that's where that communication comes into play, right? Like reviewing everything, communicating. But another thing that situation kind of reminds me to maybe mention here is that so the extent of the RT, so all the NDE that you just described, like most of the time, somewhere within the spec, there's a chart or a section or something that lays out and a line by line, depending on the valve size, the valve material, the valve service, wherever it's being installed. But this section will call out the extent of the testing that's required. So you're selling 25 of one particular valve, and this chart is telling you that you need PMI, but it tells you that you only need 10%. So, what does that mean? You got a PMI 3 valves. So 25 times 10% is 2.5. You got to round up to cover the requirement. So you're PMIing 3 valves. It's important to look for those charts so that first of all, to do enough testing, but also not to do too much. Because if you were to PMI, all 25 of those valves, again, that's where, the cost starts to build upon itself. So, definitely look out for those sections.
Sure, it sounds like that's an area of valve selection that can have a cost really pile up quickly if you're not careful with what you're doing and what you're selecting. So one of the goals of valve selection seems to be to mitigate that cost while ensuring quality and compliance to whatever standard you're trying to meet. What's an example of an aspect of valve design that can influence finding that sort of balance?
That's interesting. I guess the whole forged and cast conversation comes to mind because generally manufacturers will forge a valve up to 1.5 or 2 inches. That's really the stopping point. And at that point, cast valves take over. And the reason for that is to make a forged valve, you're basically, if you think of a blacksmith back in the old Westerners pounding a horseshoe that's glowing orange on an anvil. And it's literally taking a piece of steel that you superheat and pound it into shape. So you're compressing the grain structure and making a very strong, very high quality, durable product when you do that. And on the other hand, you have a cast. And I think about, if you're going to look at a blacksmith, I look at like a baker. So a caster or a foundry, you're literally pouring molten metal or like cake batter into a mold and running a series of treatments after the process. And you end up with something that you end up having to finish machine. But because you cast that and because you've baked a cake in your life or two, James, right? Not your life or two, a cake or two.
I need lunch yet. So tone it down with the food references.
Eat lunch like normal people and you wouldn't be worried about that. But as far as like a cake, there's bubbles in it, right? And that's porosity. And a valve, that would be called porosity. And that can cause great problems down the road because it can make it more brittle and much more susceptible for cracking. So, and to get back to your question, some people will want you to lean towards a cast valve because they're generally less expensive, but quite often it's the cast valves that need all that extra layers of scrutiny because of their penchant to become to have more problems, the porosity issues. So you may save on the valve itself, but after going through all the NDE that you need to, because it's a cast product, you totally derail any savings you may have had. So sometimes it's just better to go with a more expensive forged valve. Does that make sense?
So with NDE tests, how do you know how many or to what degree they need to be done? Is that defined by the standard or the spec that you receive?
It's defined by the spec that we receive. Yeah. Okay. And again, Dan, to your point earlier about the percentages, sometimes it's a line percentage. Like if you ordered 100 valves, it's a percentage of those, but sometimes they're going to want a percentage of each lot of each valve. So when they cook up these valves in the ovens or when they forge them, they stamp a number on them. So it might be, this might be a lot tracing B46. And you might have 6 valves that are B47, 8 valves that are B48. They might want a certain percentage of each one of those different lots tested. So that's, again, something you really need to look for in the percentages that Dan was talking about.
And the other thing is that, all right, the valve spec that you're looking at calls for PMI or calls for RT or whatever. You say, okay, I've got a PMI procedure, I've got a PMI gun, I've got a procedure for radiography. So I can just do it and that'll be fine. But that's not always true. A lot of times there's actually a separate spec entirely that tells you exactly how the PMI or the RT or whatever NDE needs to be carried out to. So just because you have your own procedure or your own way of doing it doesn't always mean that you are, meeting the intent of the spec.
Right.
So if the source of the valve that you need has to be from an approved manufacturer list or from a specific country of origin, how does that sort of influence your buying and selection process?
Yeah, that's a fairly common requirement. It's probably expected to be part of a valve specification for most projects to have an AML or a country of origin or both. So taking them one by one. So AVL, AML, that's an approved manufacturers, approved vendors list. And really it's a concise list of manufacturers that, have been selected to be able to be allowed to provide components to, whoever created that list, to the approver. So the manufacturers usually have to go through, some sort of pre-qualification procedure. It's a quality assessment. It's an audit. It's witness testing. Past performance reviews. All those things that manufacturers can do to prove that they make a product that's good enough to meet the requirements, that they have a track record of doing it. So yeah, when they have a list like that, it's because they put in the work on the front end to meticulously inspect these manufacturers' credentials and processes and products that they want to be able to leverage all that work that went into it, and ultimately minimize the potential risks by dealing with a manufacturer that they've already got experience and a good track record with. So AVLs can only be applicable to high spec critical components like motors or control valves or transmitters. But there's other times where it can also come down to literally every last nut and bolt that gets installed on a piece of equipment. With country of origin, that of course means where the valve come from, where it was made. But with, like everything else, that can be a little tricky and have some caveats, because the definition of the word origin is not always the same. So it seems simple enough, right? Where did it come from? Okay, there can only be one place, right? But the interpretation of that word can be different from end user to end user. So depending on who you ask and depending on who's asking for it, it can change. So, in some cases, it can just be as simple as, where did the last major transformation happen? So where was the valve assembled and tested, basically? Other times it's about where, the main pressure containing components are made. So where are they forged? Where are they cast?
Where the cake was made.
What bakery did that thing come from?
Exactly.
So it can be that, and it can even get down as as granular as where the raw billet came from. So again, it's important to ask the question to make sure that you understand that definition from one spec to the next.
So overcoming hurdles like that, once you have found the right valve for your application, what type of documentation can you expect to need to provide to prove to someone that the valve you have selected meets all the requirements and standards of your use?
Yep. The word proof, what you just said there that's it. That's everything. You can't just say, oh yeah, it's good. It's good. Trust me, we got it. Doesn't really work like that. We like to say in our very salesy way that you're not actually paying for the valve itself, but you're paying for the the stack of paper that comes with it. So a valve can become a paperweight real easily if it doesn't have that stack of documents, that package along with it that shows its pedigree. So what do those look like? I guess it depends on what tests and what documentation that's required in the spec. But in most cases, if you're performing a test, you're going to need to produce some sort of certificate or report that shows the result of that test. And always, 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 there needs to be a level of traceability that links that piece of paper back to the physical product. So whether that's a serial number, a lot number, a heat number, that's a common term. So basically in 10 years from now, in 50 years from now, when there's a robot working its way down the pipeline and it detects a leak, it knows exactly who to call to figure out what went wrong.
There's some good examples of things that we can keep a lookout for what you need to prove the pedigree of your valve. What are some of the specifics that you encounter in valve specification that may not be able to be done, or that may have another requirement that conflicts in the desired valve?
Yep. That's a big part of the review process. So not to frame it in a negative way, but a lot of times it's not about everything you can do to meet the spec, but more so important to identify the things you can't do, and to identify those things, because a lot of times the spec is written in a way that maybe doesn't keep in mind some of the realities of real world commercial viability. So designers of the spec are creating these requirements with their focus in mind, which is, like we say, making sure that it's ultimately safe and asking for all the things that they think they need to, ideally get a product that meets the demands. But yeah, kind of like we outlined earlier about, AMLs and COOs potentially conflicting. There are those situations that come up where either a product doesn't exist as it's written, or where two sections of a spec kind of contradict one another. So when that happens, and Kevin, we were talking about this the other day when we were looking at one, and you came up with some sort of food analogy, and I can't remember what it was.
But I was basically saying, if I'm selling you a pizza and you want a bunch of stuff on it, and for whatever reason I just can't put pepperoni on it, I just got to tell you that, right? I can't put pepperoni on this pizza, but you can have everything else.
That's what it was.
But it's important that I tell you that before you get it, and then you're upset, and now it's trouble. So real quick,
Exactly.
two other examples of that real recently. Both of these happened where a customer wanted a Teflon packing and a fire safe valve. In this particular manufacturer, there's no way they can make a fire safe valve with Teflon packing. It had to be graphite. So it was okay, but we just had to make sure we pointed that out right away. And there's another one where they needed a piston check valve, and it said spring, yes or no, no. Then it said spring material, 316 stainless. So what is it? Do you want the spring or not? So again, It's just that clarifying, making sure that you're upfront and clarifying it right at the front end of this conversation before it's installed on a piece of equipment and you're having the argument.
Yes. And it's actually most of the time it's expected that you're going to be taking exceptions, and the valve spec might even come along with a specific form that you need to use to fill out to detail all of your exceptions. So it's part of the process. It's part of the expectation. So yeah, again, it's about doing your best to identify, call it out, and work through that process of either gaining acceptance or troubleshooting.
Sounds like communication is key when trying to gain the sort of compliance that you need.
Absolutely.
Yep.
Well, that was certainly a comprehensive look at what considerations should be made and thoughts to have when selecting the right valve. To wrap things up with this episode, if you were to suggest one aspect of what we talked about today for potential valve selectors to keep at the forefront of their attention when seeking out the right valve, what would stand out to you?
Wow. I guess first, you mentioned it was a comprehensive review, and it was about the topics we covered, but there is so much more here. My suggestion would be to find a trusted partner that you work with, and get them involved with earlier in the process rather than later, because a lot of these specifications sometimes cover valves that maybe aren't commercially available. I mean, anything can be drawn up in a spec, but at the end of the day, can it be sourced, and can be sourced to the specification and in the time that it needs delivered? So the earlier you can get your trusted partner involved with these projects, the better off you'll be. We certainly appreciate when we're involved earlier rather than later. So
That's a great point, Kevin. Thank you for adding that.
thanks.
So yeah, the one thing that I would maybe want someone to take away is that you do, need to have some respect for the spec. You gotta read it, you gotta understand it. You gotta, do your due diligence, put in the work, and make sure that you're, communicating what you can and can't do. And you know what? Just have fun with it.
Well, thank you both for your insight and for sticking with us today. That'll wrap up this episode of Peerless Industry Radio. Thanks for joining.
Thanks.
Thanks.
See you guys next time.
This concludes today's episode of Peerless Industry Radio. We hope you've gained a starting perspective on valve specifications. I've been your host, James Lamb, and the speakers this episode have been Kevin Renaud and Dan Morgan. To learn more information about what was covered in today's show, see the description accompanying this recording for any links to additional materials. If you are listening to the audio version of this podcast and want to engage with us more online, check out the Peerless Inc. YouTube channel, where you can see as well as hear any future productions. If you have any questions or comments, be sure to reach out and contact us through our website or on any social media platform. Your feedback is very important to us. From everyone here at Peerless, thanks for listening, and we will see you next time on Peerless Industry Radio.